Okay, so to start with, let's look at this in memory. So we'll be going to array 1B. And then we can see the individual bytes that are there. So in this case, it starts at this address, the one that ends in 14 hex, or 20 decimal. And so there we have the byte FC again, because the zero, you can see here the zero is not part of the number, since this is a total of 3 hex symbols, but 2 hex symbols is a byte. So FC is the first value at the address 14 hex or 20 decimal. And then we have the 12 hex at address 15 in hexadecimal, or address 21 decimal. And then we have the 34 next, right? And then the DE, and then the 09. So again, the 9, we gave that as 9 in decimal, but that's a byte value, right? Meaning 8 bits or 2 hex symbols. So you're going to have that, that leading 0 before the 9. So it's 09 as a, in terms of the hexadecimal value. And so that's the 4 bytes then, right? When we put all that, or 5 bytes when we put all that together, since we had 5 terms in this array. And so that's also why as we can see here, that it's going to be in increments of 1 to iterate through the different values here, because it follows that, if the first element in the array is the address that ends in 14 hex, and then the second element is at 15, right? So, and the name of the array resolves to this address here, then if you add +1, it's going to give you the address that ends in 15, which is where the second element is. If you take the starting address of the array, which is the 14, and add 2 to it, then it's going to give you the address 16, which is where the third element is, and so on and so forth, right? So it's going to be in increments of 1 to process the elements of an array of bytes, right? So those are the 5 terms, or the 5 bytes in this array of bytes. And so again, if we want to do similar blocks that we had before, then everything is just going to be in increments of 1, right? Whether we're talking about moving all the elements one by one or into a register, or adding them up and sorting the sum. Now, like we saw before, you have to think about what level you're working at. In this case, we're working at the 8-bit or the byte level, so AX would not work here, and neither would EAX. Because array 1B is a byte in size, but we can use things like AH or AL, which are 8-bit registers, right? Because we know that EAX is a 32-bit register, lower half of EAX is AX, AX further subdivides into AH, which is the upper half of AX, and then the lower half of AX is AL. Or if you think of EAX as 4 quadrants, right, then AH would be quadrant 3 and AL would be quadrant 4. And there is no special name for the upper half or the first 2 quadrants of EAX, as we discussed back in chapter 2. So here, if we want to move all the values into, say, AL one by one, then we can do that. Again, we can use with or without the brackets. And then again, it's just going to be in increments of 1 to process the other elements in the array. So the second one is array 1 B +1, and then +2 for the third, and so on and so forth. So that's going to move the 5 elements one by one from the register into AL. Or if we want to add them all up, then it's going to be like this. Okay, and so this is all similar to what we did before, right? So just move the first one and then add the second one to the current sum in AL, then add the third element, then add the fourth element, then add the fifth element. So by the time this is all done, then you've got all 5 of them. And again, like we said earlier with the other examples, you don't, of course, you don't have to do each one twice here. We're just doing it once again to demonstrate the point that you can either use the brackets or not use the brackets, and it's going to work the same. But, you know, if we're just wanting to do it, we could also, of course, just move each value one time into AL. But like the others, to be consistent with the other examples, we're continuing the same fashion here of moving each value twice, technically into AL, once without the brackets and one with the brackets. And so we're seeing here again that it's all very similar to the previous 2 examples with word and dword. So we'll go ahead and run this now and look at the sum here. So let's go ahead and step through this. And so like before, you can always add any variable, right, or register that you're working with to the watch window. Or in this case, since we're working with AL, we know that that's the lowest quadrant of EAX, meaning the lowest byte or the lowest 2 hexadecimal symbols. So you can also interpret it that way. So AL at the moment has CC, right, which we also see there as well. And then the first block here is moving each value twice, essentially, right? Moving each value twice into AL, just to show both with and without the brackets again. So move the first value, which is the FC, right? The FC. And then move it again, so no change. And then move the second value, which is the 1, 2, right? The 1, 2 hex. And then move it again, and then move the third value, which is the 3, 4, move it again, so no change. Move the fourth value with array 1b plus 3, so we got the DE, and then move it again, so no change, and then move the fifth value. So now we have the 0, 9, and then move it again. So now we just went through and moved all 5 of those values, and then the second block here was the addition block, right? So we're going to add up all the 5 of the values from array 1b and then store the final sum in AL. So with that one, we move the first value back in again and then add up all the other 4 values. And then at the end there, we have the 2, 9, which is the sum of all 5. So, and then that's our processing our array of D words. So again, or array of bytes, since they're each 1 byte, everything is in increments of 1, right? Since they're each just taking up 1 byte total of memory.